All right, I'm going to do a quick video here about polynomials, and you see it's already filled out. I'm just going to kind of talk through this, and hopefully it'll be pretty straightforward. Follow up with me during office hours if you need to. You see here how I define, and these filled out versions of my notes are actually going to be available on Canvas as well, so don't hesitate to look at that. A polynomial is just an expression with positive integer exponents. Notice how it can be something very simple, very short, like the number 4. It could have multiple terms. Here's just 2 terms. Here, of course, this is 4 terms. It could be 100 terms long, even though I'm not going to have anything that long for you. I want you to realize that terms are separated by addition and subtraction signs. So like this is one term, 6x to the 4th. This is a second one, negative 2x to the 3rd, plus 3x squared, plus x. So that's 4 terms. Okay. Notice how I listed them here in decreasing power order, and that's called standard form. So I started with the highest power, went to the next highest, went to the next highest, and there's an invisible 1 here. And if I had a plain number, I would put that at the end. I didn't have one there. Okay, a constant is just a number without a variable. It's just a plain old number. Like this 4 up here, that's the constant. This negative 2, it's a constant. It's called a constant because there's no variable with it that would change the value of it. That's negative 2 is always going to be negative 2. And you see the coefficient's just the number in front of the variable. So like here, if I wrote 3x, that 3 is the coefficient. Up here, this 8 is the coefficient. This one has 4 coefficients, the 6, the negative 2, the 3, and remember here there's an invisible positive 1, okay? You guys have probably heard those terms before. Now the leading coefficient is the coefficient of the term with the highest degree, the highest power. So this thing here, the leading coefficient is not the first thing, the 6, it's the negative 9 because the negative 9 is in front of the variable with the highest power, okay? Up here, like the leading coefficient would be 6 because x to the 4th is the highest power, it comes first. Now, what I did here is I changed this expression to standard form. I wrote the highest power first, then I wrote the next highest power, and then I finished with the 5. Okay? And the degree. So the degree is the largest degree of its terms. It's the highest power. So you see, this would be called a 5th degree polynomial. Okay? Now down here, guys, you'll see we've got this chart. I've already filled the chart in. You can fill it in now. You can fill it in later. So we have 2 things we're going to consider. We're going to consider the degree, and we're going to consider the number of terms. Now the degree, remember, is just the highest power present of the variable. Here there's no variable at all. That's why that one's 0. Here there's an invisible 1. Invisible 1. Highest power is 2. It's just the highest power that we're looking at. Okay, there's a 4. There's a 9. That's what that's coming from. Now there's some special words associated with this. So if you have a degree of 0, that's called a constant. Now we're talking about terms on the right. See, there's just one term here, and that's called a monomial. So that prefix mon, many of you have heard before, of course, means 1. Now this next one is also one term, so that's a monomial as well. But you see that it's an invisible power of 1. That's why the degree was 1. And that's called linear. So that's a linear monomial. You see this one's linear as well. But it's got 2 terms. That's a binomial. 3 terms is trinomial. That should make sense, these first 3. Pretty easy. But you see, once you get above 4 terms, then it's called a polynomial with however many terms. Okay? This is a polynomial with 4 terms. If it had 8 terms, you say polynomial with 8 terms, and so on. Here the highest power is 2. That's quadratic. Highest power is 3. That's cubic. So there's a bunch of new terminology here you got to be comfortable with. There's only one more new term you need to know here, and that's the highest power being 4, the degree of 4. That's quartic. Anything above 4, you just say like that's a 9, so that's ninth degree. If the highest power had been 6, it would be 6th degree. 7 would be 7th degree. 5 would be 5th degree. So there's no special word above 4. There are special words from 0 to 4, constant, linear, quadratic, cubic, and quartic. But anything above that, we just say degree. Class by terms, there's special words for the first 3, monomial, binomial, trinomial. Anything above that, it's polynomial with however many terms we're talking about. Okay. This next, now we're actually doing some operations. We're combining like terms. So what we do is we just combine like terms. Start with the highest power present. So you see the highest power is 2. So negative 4x squared and 6x squared together, that's 2x squared. The main thing is when you're combining like terms, guys, the power doesn't change. Now we go to the next one, the next lowest power, which is this invisible 1. But you see negative 2x and positive 2x, they cancel out. So I don't write x at all. And then the plane numbers, the constants go at the end. 5 minus 11 is negative 6. And you see that's a quadratic binomial. Classify means to name. On this next one, you guys will notice that the highest power is 4, but you see those cancel out. So that's gone. You don't write x to the 4th power at all. And the next highest then is 3x squared, but there's nothing to combine it with. So I just bring that down. The next one is the 5x. I just bring that down because there's nothing to combine that with either. And then I combine the negative 24 and the 16 to negative 5. Okay? You should try this next one yourself. I'm hoping it makes sense. 17, negative 8, and negative 11 is negative 2, x to the 3rd. And then just go down the line. Okay? Now, down here, this is subtraction. It's a little bit different. There's just one thing that's different versus addition, and that's in the very beginning. Notice how I crossed out the words. I just kind of put these in parentheses and wrote subtraction in between. I think that's a better way of looking at it. In our first step, guys, I'm going to remove these parentheses and just bring this stuff down. Nothing changed here in the beginning. But what I'm doing here is there's an invisible negative 1. I am distributing that negative 1 to each of these things in the back end. So negative 1 times negative 13x to the 4th is positive 13x to the 4th. Negative 1 times negative 3x squared is positive 3x squared. Negative 1 times 2x is negative 2. You see, so all the signs ended up changing for this stuff in the back half. Now we just have this one, we have no more parentheses, we have one long string, and now we just combine like terms like we did before with addition. 8x to the 4th and 13x to the 4th is 21x to the 4th. The next highest power is the 2, but those cancel out. Negative 11x and negative 2x is negative 13x. You see? You can try these next two yourself. Okay? The main thing is, again, distributing this invisible negative 1 first. Then you combine like terms. Start with the highest power present and go down each successive power until you end up with just the plain numbers at the end. Okay? Now I'm going to continue this video with some factoring. Now this thing up top, this is just a change to standard form. I talked about that earlier. This first thing is not written in standard form, and I then changed it to standard form. Okay, factoring is something totally different. We're going to factor out the GCF, which is the greatest common factor. So I'm giving you this thing, and there's two parts to factoring out the GCF. First, you ask yourself, what is the biggest number that divides into 2, 8, and negative 6? And I hope you realize quickly that that's 2. So 2 comes out front. And then you look at the variables and you look at what's the smallest power present. Smallest power present is x squared. That means each of these terms has at least x squared in there. So you can take out x squared, okay? Then you ask yourself, 2x squared times what gives you that? Well, 2 times this invisible 1 is 2. Remember, when you're multiplying, you add these powers. 2 plus 2 is 4. 2 times 4 is 8. 2 plus this invisible 1 is 3. So that's why we have 4x here. And then here we don't have x squared x at all because we only had x squared and we took it out there. So 2x squared times negative 3 is negative 6x squared. So essentially, this times what will give you these things up there. Okay? And I'll talk through the next one. Again, the biggest number that goes into 15, 12, and 3 is 3. That's where that came from. But notice how there's no variable in the front. And that's because there's no variable here. The lowest power present is actually, you don't have x at all. Because you don't have x at all in this last thing, you can't take x out. It's not common to all three of those. All right? So 3 times 5x squared would give me that. 3 times this would give me that. 3 times that. 3 times 1 would give me that. Maybe try this next one. Again, you can take out a 2, but the lowest power present, x squared. I'm hoping this makes sense. Take a look at that. There's another example, number 4. You can look at yourself. Number 5 is what this is an example of. Sometimes, you see, there's actually not a number that goes into 6, 8, or 11. So there's no number out here. But I can pull out the lowest power present, which is x to the 5th. And you see how all these powers were reduced by 5. See, instead of 7, I now have 2 there. Instead of 6, I now have 1. Instead of 5, I now have none. I don't have x there at all. And here's one with different variables. But it's the same idea. I can still take out 3 from 12, 15, and 9. Boom, did it. And then what's the lowest power of x present? X squared, take it out. What's the lowest power of y present? Just this y, take it out. And then the powers get reduced appropriately. All right? See me if you need help.